right, then let's take a look at example 3.2. So far, we've only dealt with large numbers, like 82,300. In example 3.2, we are going to deal with a very, very small number. Example 3.2 says, convert 0.00005791 to scientific notation. Write the scientific notation rounded to one decimal. So note it says, write the scientific notation rounded to one decimal. If we wrote the original number rounded to one decimal, it would just be 0.0. Scientific notation actually focuses right in on the part of the number that has the information. So our scientific notation for this number is going to focus in on 5, 7, 9, and 1. I'm going to write it first with all of the decimal places, then I'm going to round. So to convert this number, I'm going to use my hopping decimal point. There are many ways to do this, but you have to account for how many places you're moving the decimal. And this is the one that happens to be my favorite. So I'm going to take my decimal point. I'm moving it 1 to the right, 2, 3 to the right, 4, 5. The reason I'm going to put it here is it's going to put one digit in this number, non-zero digit, to the left of that decimal place. So that's going to get that first part of my scientific notation to be between 1 and 10. How many hops did I make? 1, 2, 3, 4, 5. All right. So I'm going to rewrite 5.791. Like I said, I'm going to round in a separate step. Now, to move this decimal in this way actually requires us to divide by 10 at each point. To signify that, we make the exponent negative. So the number of steps from the original decimal place is still the number, right? So we went 5 steps from the original decimal place, but because we went in this direction, we have to make it negative. Now that I have it in scientific notation, I'm going to go ahead and round it to one decimal. So the second decimal place is 9. That's greater than 5. So I am going, or 5 or greater. So I'm going to round the first decimal place up to 8. What that's going to leave us with is 5.8 times 10 to the negative 5th. Now this could also be written 5.8 e to the negative 5, 5.8 e to the negative 0.5. When you have that negative exponent, that negative symbol always has to be there. So these are equivalent. Before we back out of this and see how the hopping works in the other direction, let's talk about what 5.8 times 10 to the negative 5th means mathematically by talking about what 10 to the 5th means mathematically. So 10 to the 5th power is 100,000. And what it means when you put a negative sign on an exponent, 10 to the negative 5th now, is that you take 1 over whatever that number was. So in this case, 100,000. So essentially, this expression, 5.8 times 10 to the negative 5th, is the same as 5.8 times 1 over 100,000, which is the same as 5.8 over 100,000. So you see you're dividing by the 10 to the power instead of multiplying when you're dealing with small numbers in scientific notation. So what does this do mathematically, this calculation here? 5.8 divided by 100,000. Well, we know what it does mathematically. It gets you 0.000058, right? Or 5791. But if we do the hopping like we did before, we would start with the part on the left of the scientific notation, which is 5.8. And we see that the exponent on the 10 is negative 5. What that means is that we have to take this decimal point and hop it 5 steps to the left. So I'm going to go ahead and do that. I'm going to go 1, 2, 3, 4, 5. Place the decimal there. What's next? Fill in these empty cups with zeros. 0, 0, 0. And we get our original number back. Of course, you can put a 0 before the decimal or not. Now, we didn't exactly get the original number back, though, did we? Because we rounded it when it was in scientific notation. The thing about scientific notation is it is display only. So when you see scientific notation in Excel, you should know that the numbers that you are not seeing are not necessarily going to be zeros. Excel will often round its scientific notation, just like we did in this, in order to display it more efficiently. But if you actually click to highlight the cell in Excel, you may see that there are many more digits than are showing in the rounded portion. All right, turning to example 3.3, we're asked to convert 1.23 times 10 to the negative eighth back to decimal notation. So of course, this is the more modern way to write 1.23 times 10 to the negative eighth. To convert it back to decimal notation, we've got to move that decimal 8 places to the left. That is what this negative 8 exponent means. So what decimal point do we have to move 8 places to the left? The 1 in the 1.23 part of this notation. So I'm going to write 1.23. I'm going to take that decimal point and go 1, 2, 3, 4, 5, 6, 7, 8 places to the left. I'm going to fill in the decimal here and erase the decimal there and fill in each of these cups with a 0. 0, 0, 0, 0, 0, 0, 0. So notice the exponent was negative 8, and we now have 1, 2, 3, 4, 5, 6, 7 zeros. So one fewer 0 because we've got to go one more decimal place to get to 8. Many times you would write a 0 on the left-hand side just to make this number look good. But who are we kidding? It looks terrible. And looking at it, you can see why 1.23 times 10 to the negative eighth is preferred for display. Moving ahead to example 3.4, we're asked to convert 7.642 times 10 to the positive eighth back to decimal notation. So once again, the classic way to write the scientific notation is 7.64 times 10 to the negative eighth spelled out, but this notation with the E is the notation that you will see in Excel and many calculators. Now, the positive 8 exponent means that you have to take the decimal point and move it 8 places to the right. And then we're going to fill in the empty places with zeros. So we're starting with the number 7.642. Take that decimal point and move it 1, 2, 3, 4, 5, 6, 7, 8 places to the right. I'm going to put that decimal there. I'm going to erase the decimal here. And I'm going to fill in each of these cups with a 0. So what you get is 7.642 0, 0, 0, 0, 0, which is 764,200,000. Before going on, let's reflect on these two examples. So we had, in one case, convert a number in scientific notation with an exponent of negative 8. And in the other case, convert a number in scientific notation with an exponent of positive 8. What was the difference between the two? The difference was that when the exponent was negative, you had to take the decimal point in the number, move it to the left as many places as the magnitude of the exponent, in this case 8 places, and fill in with zeros. That's going to result in one fewer 0 than the number in the exponent between the decimal point and the first non-zero digit. Another way to remember this is that when your exponent is negative, your number should be small. Your exponent is negative, the number you end up with should be small. So that's why you're taking the decimal point to the left. In example 3.4, we also had an exponent of 8, but this time positive, so we're still stepping the decimal point by 8 places, but this time to the right. So the positive sign on that exponent means the decimal place has to go from where it is in scientific notation that many places to the right, and fill in with zeros as necessary. So scientific notation with a positive exponent represents a large number. Positive exponents mean large numbers. Negative exponents in scientific notation mean small numbers. Scientific notation can be used for any number, but usually it's only used when numbers pass beyond a certain comfort zone in terms of how large or how small they are when you're writing them or when you're typing them. The final fact that will be useful about scientific notation is that the larger the exponent in the scientific notation, the larger the number is. The smaller, meaning the more negative the exponent, the smaller the number is. So when you're looking at a spreadsheet that's full of numbers that are in scientific notation, you can very quickly assess which are larger and which are smaller relative to each other by looking at which has the higher exponent. Higher positive exponents are bigger numbers. In example 3.5, we're asked to order the following numbers from smallest to largest. Now there are 7 numbers here, so I'm going to make a list numbered 1 through 7 to go from smallest to largest. So the first thing to do when confronted with something like this, when everything is in scientific notation, is to take a look at the exponents, and we're going to order these numbers by their exponents. So we see that the exponents go at the low end, and by low I mean lowest negative number, so most negative, is -6. Then we have a -5 exponent here. I see a -4 and a -4, so there's 2 -4 exponents. Then we have some positive exponents. We have a positive exponent of 7, another positive exponent of 7. Now neither of these shows the plus sign, the positive sign, but since there's no sign, that implies that these are positive. So there's 2 that have the same exponent, and then we have a positive 12 exponent. So the first thing we can do is definitely order by exponent, and then within exponents, we're going to have to look at the number that is to the left of the multiplication sign and just compare on that basis. So the smallest number here is going to be 3.2 times 10 to the -6th. Now for next smallest, we have an exponent of -5. -5 is 1 step to the right from -6. If you think of a number line, it's 1 step closer to 0. If you think of it that way, it's 1 step less negative. So in any case, it's bigger. It's bigger than -6. So that means that 9.4 times 10 to the -5 is bigger than 3.2 times 10 to the -6. Now next we have 2 numbers that have -4 as the exponent on 10, 1.1 and 7.4. And in this case, since they're within the same exponent on the 10, we just compare the 1.1 and the 7.4. So 1.1 is smaller than 7.4. 1.1 times 10 to the -4 is the next largest, and 7.4 times 10 to the -4 is larger than 1.1 times 10 to the -4. Moving on, we get to the 2 numbers that are at the exponent 7 on the 10. 1.79 is smaller than 4.8, so 1.79 is going to come first. 1.79 times 10 to the 7th, then 4.8 times 10 to the 7th, and then finally we get to our 2.8 times 10 to the 12th. And I'll put the positive sign in there just like it is in the listing, but I could leave it out and it would mean the same thing. So once again, when looking at a bunch of numbers in scientific notation, which you frequently will when using spreadsheets to do calculations, you can order them according to the exponent. The largest negative exponent, that's actually the smallest number, that's the smallest exponent, that is the smallest number. And the largest positive exponent is the largest number. if you have two numbers in scientific notation, you can compare their magnitude by looking at those exponents.